Hello and welcome. My name is Shannon Kemp, and I'm the Chief Digital Officer for DATAVERSITY. We would like to thank you for joining today's DATAVERSITY webinar, Engineering Data Quality, a Framework for Effective Data Management, sponsored today by Reltio. It is the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken. And just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them via the Q&A section, or if you'd like to tweet and if you would like to chat with us or with each other, we'd certainly encourage you to do so. And to open and access either the Q&A or the chat panels, you can find those icons in the bottom middle of your screen. And just to note, the Zoom chat defaults to send to just the panelists, but you may absolutely change that to network with everyone. To answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days containing links to the slides. And yes, we are recording and will likewise send a link to the recording of the session, as well as any additional information requested throughout the webinar. Now, let me turn it over to Kim for a brief word from our sponsor, Reltio. Kim, hello and welcome.
Thank you, Shannon. Great to be here today. My name is Kim Toomey, and I'm a senior solution consultant with Reltio, a leader in the data unification space. Today, we're going to talk about how enterprises should be thinking about engineering scalable data quality practices to enable effective data management solutions, whether you're leveraging that data for analytical uses, operational, or AI-based solutions. We know today that data quality is the biggest factor that's hindering scalable AI adoption across enterprises. Companies are quickly needing to rethink data risk. What can your organization tolerate when it comes to data quality and data fragmentation? For most, that bar has been raised. We've all heard the phrase garbage in and garbage out when it comes to data, particularly in the analytics and BI space. But now that companies are investing millions of dollars into agentic projects, the importance of good quality data is more critical than ever. And look, everyone has a data mess. You are not alone. And we know that data is important, but for most, you'll need to approach this challenge in phases and don't boil the ocean all at once. So let's break this down. First and foremost, engineering data quality means identifying whether issues stem from how data is managed or how from those systems are structured. And Reltio enables both perspectives by unifying data across silos, giving teams a comprehensive, real-time view to quickly pinpoint root causes. Next, a proactive data quality strategy requires transparency, lineage, and built-in rules, not just ad hoc cleanup. Reltio provides governance at scale, ensuring that trusted data flows consistently across operational systems, analytics, and AI tools, supporting continuous improvement. And Reltio really goes beyond just dashboards and deduplication. Reltio delivers continuous data curation, automated matching, and semantic data modeling, all core elements of data quality engineering that prevent problems from recurring and reduce the cost of remediation. Having this data at the ready is now table stakes if you want to be able to deploy cutting-edge strategies around AI and user experience. Reltio Data Cloud is a platform that enables not just mastering, but continuous data quality management, so you can offer your enterprise a trusted data product. In the Reltio context, a data product is the combination of 3 things: a trusted governed entity with unified attributes across source systems, and that entity is linked natively with relevant interactions, data, and then lastly, enriched with derived attributes. Reltio is also going to publish metadata about these data products into your existing data catalogs to ensure that data sets are discoverable and described in rich detail. To accomplish this, real-time intelligence is required to bridge the gap between legacy apps and agentic workflows. The Reltio Intelligent Data Graph is the core capability that delivers on that. Our API-first approach has allowed us to manage records in real time, resulting in profiles that are continuously curated and context-rich. And what makes this truly impactful is that this incredibly rich context is all connected. So you can extract the full meaning of all this data because you understand how it's interconnected. But you also need to be confident that your data consists of high-quality data. Our comprehensive data quality capabilities offer continuous and automated monitoring with real-time visibility all in one place. unlike most MDM and standalone data quality solutions that offer point-in-time insights. Reltio supports automation of data quality processes, and in some cases, even partners with third-party solutions to further enrich and verify your data, including addresses, phone numbers, and emails. But of course, you don't want to just take my word for it. Reltio customer Eaton, founded in 1911, works to make a positive impact on the world by giving people the tools to use power more efficiently. In this complex environment, Eaton was able to create reusable enterprise data assets to connect data across over 90 systems and ultimately improve data governance, quality, and productivity throughout the enterprise. Interoperable data, like what Eaton built with their data foundation, is what allows you to compound your enterprise value and support a variety of use cases across your business. Whether it's driving marketing and sales effectiveness or improving customer experience, this data asset can truly power your business when governed and managed with an eye towards continuous data quality improvements via automation. Thanks for learning a little bit about Reltio today. For now, I'm going to hand it back over to Shannon. Again, please feel free to put questions in the chat or in the Q&A, and we can take them at the end of the webinar. Back to you, Shannon.
Thank you, Kim. And ooh, I love a good QR code.
Yeah.
Thank you for that. And thanks to Reltio for sponsoring today's webinar and helping to make these webinars happen. If you have any questions for Kim, as she mentioned, she'll be joining us for the Q&A portion at the end of the webinar, so feel free to put that in the Q&A panel. And now let me introduce to you our speaker for the webinar series, Dr. Peter Aiken. Peter is an acknowledged data management authority, an associate professor at Virginia Commonwealth University, president of DAMA International, and associate director of the MIT International Society of Chief Data Officers. For more than 35 years, Peter has learned from working with hundreds of data management practices in 30 countries, including some of the world's most important. Among his 12 books are many firsts, starting before Google, before data was big, and before data science. Peter has founded several organizations that have helped more than 200 organizations leverage data-specific savings, which have been measured at more than 1.5 billion US dollars. His latest is Anything Awesome. And with that, let me turn everything over to Peter to get his presentation started. Peter, hello and welcome.
And welcome to you, Shannon. It's so good to be with everybody on this Tuesday afternoon. Our title today, of course, is Engineering Data Quality, a framework for effective data management. And I think that it's really worth calling back to what Kim was just describing in Reltio, in the sense that if nothing else, having all of your data accessible via one constant means that everybody can learn can in and of itself be enough to improve data quality in organizations in very, very specific and measurable ways. So we're looking forward to Kim joining us at the end of the hour here so that we can dive in a little bit further on some of these topics. But between now and then, we're going to take a look at three major areas. One, approaching data quality, which is to say that unfortunately many organizations are still discovering. Think about our sample size that we have here. We have people who are interested enough to take part of their day and donate it to listening to something as obscure as data quality, right? So we're a relatively small subset of this, and most people just haven't even discovered that this is a problem. The next question that you ask after you sort of approach it in a way that works for your organization, your situation, is what do I now need to get better at in order to improve data quality and also improve the effectiveness with which I am trying to improve data quality? And then how do we specifically get it better around those areas? The short answer to this, just so you guys are jumping ahead, is PDCA. If you don't know what that is, stay tuned and we'll get to it. But now let's talk about how to approach these topics. And I'm going to give you this as between two potential things. This same set of comments I'm going to give you applies to warehousing and it applies to cloud. Now, most people think cloud is more exciting today, but nevertheless, watch and I'll show you what the problem is. The problem has been typically something called forklifting the data into some place when you're moving it from one place to another. And that is almost always proven to result in a slight decrease in the quality of the data as it's moved over there. Things happen during the move that cause it to do it. But there are additional problems. There's no basis for inclusion or exclusion of any of those data items. And I'll show you a little bit later on that 80% of your data is redundant, obsolete, or trivial. So there's no point in trying to duplicate it in a warehouse as far as that goes. Just identify it, understand it, and then exclude it from that warehouse or that cloud application. There is no inclusion of architecture or engineering concepts. We're simply moving tables to tables via spreadsheet concept. There's no idea that these concepts are missing from the process. And as I said, 80% of your data is rot, but there's no then appropriate trade-off discussions that are made. For example, there are things that you should do in the cloud or should do differently in the cloud that violate traditional database programming norms. And we can go into that later on if you're interested on it. But of course, what should happen, whether you're moving to a warehouse or to the cloud, is that this is an opportunity where the data can be, and also is understood to have transformed, whether it has been transformed or not. That's unfortunate. So you have data in the cloud or data in the warehouse in Peter's world is less in volume. That's mainly because you've gotten rid of 80% that is redundant, obsolete, or trivial through some careful engineering analysis that oftentimes will pay for the cost of some of these things that we're talking about in that process. In addition to that, the information should be cleaner. Now, I don't think anybody would say it should be dirtier. So we'll just go with cleaner and say, yes, it should definitely be cleaner inside. And that gives us an opportunity in a minute, I'll show you. But by definition, by putting it in some place where it's accessible via a single application in there, as the Reltio Cloud was, for example, it makes it more shareable because everybody knows they only have to learn one thing in order to get access to it. And that can make a significant difference. Now, the part I was talking about from cleaner is a concept called data branding. And it's not anything particular other than if you can say your data in here is of known quality, which is a good thing to know. It's generally helpful to be able to have that. And then you say of known quality generally is better quality than data elsewhere in the organization. So it becomes a preferred area. And you say, we get it from the X portal, or we only put something in the X portal if we know and understand the characteristics of those quality. Just taking that as a structured approach will help your organizations much better understand it, because their perception of it now is that you put the data out there in the cloud. Now it's even harder for you to access it. It's kind of like trying to say there's a data quality problem here at the bottom of Niagara Falls, whereas the data quality is clearly miles and miles upstream. There's not so much we can do about it. Well, let's start by dividing the world up into 4 parts: data quality attributes, data model attributes, data value attributes, and data representation quality attributes. These are generally accepted as, on the left-hand side of your screen, they tend to be practiced oriented. And again, Kim mentioned that in her talk as well, although we'll have to have a conversation about who invented it first, right, Kim? No, just kidding. Anyway, the other side of this is the right of your screen. They tend to be structure related data quality challenges. And unfortunately, more people are familiar with the left-hand side of the world than they are with the right-hand side of the world, but the leverage is clearly greater on the right-hand side of the world because, of course, of the one-to-many relationships between each of these categories that are in there. I know that's a bit academic, but it's important. And let me illustrate all this. If we take these as the quality dimensions, again, the idea is to get data that is fit for purpose, and practice related means we're not capturing things well. We're allowing things to get presented out of sequence or otherwise impacting on data value and data representation. For example, the number may be 42, but you may only see 2, in which case you can't get in on the joke of 42. Ask me at the end for it. If it's structure related on the other side, though, the data can be arranged imperfectly. You may have street address and GPS coordinates. I'll show you an example of that in just a minute. All of these add up to be more substantive kinds of changes, and the changes that are harder to make in existing off-the-shelf software, whether it's an ERP or anything else along these lines. Here's a good example of data quality, though. If you go in for surgery, they will have you mark the knee you're supposed to have surgery on and put an X on the one that you don't. Again, good idea, right, as far as that goes. Here's the launch to other conversions on this. New York's trying to solve the idea of they've got 2.5 million trees, and during just 11-month period, 4 people in the city were killed. So it was worth some time and attention because each of those was a lawsuit, I assume. Arborists saying make trees better is really great, but we didn't have any data to do this. So they decided to hopefully get a group of students involved in it. But anyway, some data scientists somewhere sat down and said, does pruning trees in 1 year reduce the number of hazardous tree conditions? And there was lots of data that had been collected, but it was pruning data that had been recorded block by block, whereas the cleanup record had been recorded at the address level. And literally, trees don't have unique identifiers, so it was difficult for them to cross map. After downloading, cleaning, merging, analyzing, and intensive modeling, they did find that pruning certain types of hazard caused a 22% reduction in them. But more importantly here, do you see the mismatch between the data as it was collected on one level for one application and used on another? A standard data collection method would have helped improve the data quality in this particular environment, because everybody's still trying to figure out how all these pieces get together. And again, a quality flaw can keep that from happening on this, not knowing, of course, that they're all the same person. I'm going to do that one just again here because I like to narrate over top of it the second time that I do it. Who is Joan is the question, and she comes in from the website where the autofill on her browser has filled out the information here as J.E. Smith. And the call center operator had wax in their ears that day or a bad connection or something and wrote the name down as Joni Smith, not Joni Smith on this. And the third-party data list that this organization was sold had her Joan E. Smith, again, incorrect, different variation thereof, not knowing, of course, that all 4 of these were in fact the same person, and that one set of marketing materials towards them would have been helpful, and that improved data quality can do exactly this kind of thing. By the way, the reason I show you these examples is because I fully hope that you clip them off of YouTube and use them in your own organization to make the same point with your voiceover instead of mine, because that is the purpose of this community. On here, I'll also talk to you about feedback at the end here because I got some great feedback on this one. But what it really gets to is we can't be digital without properly spelling data. And if we don't spell it right, it's going to be problematic all the way around. Again, there's the idea that one random project in Nebraska, can create the entire crush. Well, that's really, it's data, and it keeps being data. It's unfortunate, but data quality is a limitation on how good any AI, much less any output of anything, can be. In fact, of course, we can talk in general that bad data plus anything awesome, whether it's AI, master data management. By the way, I heard a new term for it used in Europe. It was called key data management. So maybe that's our acceptable substitute on here. But anyway, bad data plus anything awesome gives you bad results. And as Kim said, garbage in, garbage out. Although I was corrected recently, I took a trip to the Midwest, and one of the Midwest niceties up there was, you could say garbage in, garbage out, and that's negative. But if you actually say goodness in, goodness out, that will give you a better result. And by golly, let's just put some positive universe energy out there, right? I'm enjoying the feedback all the way around here. So you can see what's happening here is a really good illustration of it. Doesn't matter what you have at the center in there, because all of it is dependent on quality data as an input in order to come up. And this is always going to be true in terms of that. When we look additional beyond that, though, what we're also seeing is that consolidating data that's flowing to and from places can be actually very, very significant cost savings areas for organizations that are there. We can catch that at the break, but one of the things you should do is regularize your data flows into and out of whatever your major systems are, so that they are as efficient as possible. And now that you have good numbers going in, you can now evaluate the outputs on this. The major area that organizations, it was a disappointment, I guess is the best way to say it. A data scientist typically takes 3 years in an organization to get acquainted. And the reason is they're not taught anything about data quality. They're smart people. They could learn this. Although, quite frankly, thinking very practically, this is a lower price point than a data scientist. So you may want to, my ratio is add one really good data engineer, data analyst type to a team of 10 data scientists, and you'll make the entire team much more productive around that. So what do we mean by data quality? It's fit for purpose. Martin Epler coined that many, many years ago. And it's synonymous with information quality, since we have data that makes up the information. It's the inputs controlling the level of the outputs. There are some significant activities that you want to include in this, and I'll show you on it. But before we get there, I want to tell you the story of Popeye, because Popeye was fun. I grew up watching Popeye cartoons and thought that Popeye had this great thing of spinach that made him super, super strong and all the rest of that that goes on. I've given a link to it at the bottom. But it turned out, interestingly enough, that the measurement that was done at the government, the Bureau of Labor Statistics, they made an error and they were off by an order of magnitude. It was recorded that way, but it wasn't corrected for 50 years. And so literally that is why we think spinach is such a wonderful, by the way, it's a good vegetable. It's as good as all the other leafy green vegetables, but it's not a superfood, unfortunately. Again, data quality error that occurred 50 years ago, and look what resulted in terms of the popular culture. Many of these are very much appropriate of the story, The Princess on the Pea by Hans Christian Andersen. I've circled the pea down there at the bottom, and up at the top, of course, the princess sleeping on top of all of those comforters and things like that, mattresses. They're still uncomfortable because the pea is at the bottom. And data quality problems that are built into your products when they're sold become that way for life. They stick around, and it becomes very, very difficult because they lock in these imperfections for the life of the app. They restrict your investment benefits and decreases your ability to leverage. 40 to 20% of all IT budgets are spent migrating, converting, or improving data. All of these are quality related types of activities in there. And not doing this causes everything to take longer, cost more, deliver less, and present greater risk. Another factor that you have, in addition to data quality problems, and I'm not sure whether it would be a data quality problem or a separate category by itself, but data debt is something that you encounter, which is that you have to clean up some stuff and kind of get back to zero, undoing existing stuff and likely demanding new skills of your team in order to do this, because data debt is the kind of thing that, once again, slows down progress. It decreases the levels of quality that are there, which is an impact directly on data quality. Of course, increases the costs, which gives you another place to save money on this and presents greater risks for doing this. And the question, as I said, we're going to go to the idea that not all data is equal, and the idea of separating the wheat from the chaff. You first ask the question, is well-organized data worth more? The answer should be yes, thanks to wonderful author Abby Covert in here. She puts forth the example: imagine handing somebody a book and having the pages be out of sequence, the tables not be in alphabetical order, and diagrams numbered randomly. Some examples of Abby's work up here on the screen. She's wonderful, and her book is called How to Make Sense of Any Mess. Wonderful book for information architecture that is not for information architects on here. So you now have a good explanation of why data organized is worth more. Now, if we take the spine off the book and distribute the pages without page numbers on them, of course, the knowledge is ephemeral. It disappears rapidly, and therefore better organized data increases in value, but 80% of your data out there is redundant, obsolete, or trivial. And the challenge is, of course, finding out. Again, it gives you a 4 out of 5 chance on a random walk, but you can also use some techniques, data quality techniques, to go in and identify those aspects of it. But who in your organization is best qualified to do this? And the answer is, of course, you're people who eventually you want to be data stewards and involved in data governance in the organization, because governance is about providing leverage to the engineering folks, making sure that they have the ability. It's controlling the materials that come in. And while we understand a lever is an important aspect, if I have a 1 kilogram versus 100 kilograms, I'm going to need quite a long lever to balance them all the way out. If I increase the leverage there, the size of the weight of the round piece, it's going to come up to a better, flatter piece. And if I increase it still further, of course, I'm going to get better leverage. The reason this is important is because it makes, first of all, our great opportunity to label the parts here. We've got our organizational data, and this is always a three-legged stool, excuse me. And in terms of three-legged, you need to have some technologies. The first one is the lever itself. The second piece is the fulcrum part of the lever. Most people assume it's one thing, but it's actually two. And the people are where you're getting your leverage on the other part of this. And as the people go through the processes that you want them to do, guided by a strategy within here, you end up with a situation where they're able to decrease the amount of rot and therefore increase the leverage, as illustrated thus. See, it goes there, And then it goes up. Quality data, however, is assumed way too often in these situations. And the data leverage is a multi-use concept, and that we're going to use it over and over again within the organization across our exchange partners in support of the mission. Remember the comment I made about simplification at the very beginning. Leverage is, of course, enabled by metadata. The reason we don't do it now is because we have too much metadata. We'll have we will have less metadata, littler metadata. That's a very bad example. Yes, we'll have less metadata, and that will make it easier for the organization to do it. And if you truly achieve that leverage of 80%, you've got a very significant savings. The only argument I've ever gotten from organizations in 30 years has been some organizations that come to me and say, Peter, it's actually 90%. So I didn't tell anybody. I'm just giving you the idea. Let's look at another example of data quality leverage and why the importance of engineering is so critical to this. If I talk about reference data, again, I mentioned this at the beginning, most people are saying master data is a bad term. We should call it key data. So we could call it reference and key, but let's just try it and see how it works. Reference data is the smallest quantity of data that we have, so it makes sense that controlling it better would be in our worthwhile to do. And this idea is like, what countries do we do business in? What types of accounts are available? What are controlled vocabulary items within our environment? They control the accessible data values. We might, for example, be stuck not being able to do business overseas because our reference data was not broad enough. It had no consideration of country code, which meant it had one country code that could be put in. And yes, you can retrofit these things, but it's generally very expensive. Master data, again, suggestions call it key data. Are you members of our premium club? Are you authorizing use or users, common data standards? This master data is critically important information on each of the key business objects about which we create, read, update, and delete information. We might not be able to determine the product of origin or add a foreign language to a website if we haven't got the right type of master data. And then there's all the rest of the transaction data in there that says you just spent $5 for a Coke in the Coke machine in Switzerland. That's about the right price. Again, wonderful. I'm going to be visiting there next week, so we'll see how maybe somebody will remember that. Anyway, transaction gives you the instances, the values and things that are here. By the way, I want to say thanks to Chris for letting me use this example because it is absolutely his on this. All right, so let's take a couple of quick examples, just spend a few minutes and dive through. I'll show you the IRS anti-coronavirus payments as one, a letter from a bank, a very expensive, small data rounding error, a health data story, a chocolate story, and another COVID-19 story. So the first one is, we get a headline like this one on the bottom here. Treasury sent more than 1 million coronavirus stimulus payments to dead people. Congressional watchdog finds. Now, that's certainly one way to report it, but the Slate had a much better approach to it, which is the idea that if you look at the numbers, they had 160 million payments to send. The ones they sent to dead taxpayers totaled 1.1 million of them. So the error rate was actually 0.4%. Quite an acceptable rate of error considering that they were trying to get this money to people in 2 weeks. It was also determined later on that they had to send it to dead people because they weren't entitled to remove that money from these people's estates, even if they had passed on. So again, the headline should have been, the government did its job really well. Speed was the priority. And we now have some good evidence of how to do things differently economically when you look at what's happening in all of these. And they should have gotten an award for all of that instead of getting beat up in the paper. Poor data people. Here's another thing that oftentimes is not recognized as a data error. In fact, this occurred to me. You can see it's dated quite a bit, but nevertheless, I took this piece of paper when it came in and I crumpled it up and threw it in the trash because I did not have an account with SunTrust Bank at the time. The problem was the bank didn't know it had made an error. And when I pulled it back out, I went and actually called up SunTrust and said, hey, did we really get a gift certificate? This is wonderful. Thank you so much. What can we spend the money on here? How will it work? Again, you see the issue. $0 should never have passed any of the filters on the other side in order to make it to here. But people don't think these are data quality errors. Yes, they are. I'm a senior member of the IEEE. That means I've paid them dues for 30 years, I think is what it is. And last time I logged on, it told me I had been a member for 3 minutes and 4 seconds. You can't make this stuff up. Here's a very expensive mistake. The trench was supposed to be 2.52 inches, and it was delivered as 2.5 inches, close enough, no, not at all, delayed the city of Seattle's port construction at a cost of $1 million and rising on this. I have one company that I work with where I go in and I just have to start telling us, and they can tell from the tone of voice or from some keywords that I use. They'll say, "Oh gosh, Peter, are you going to tell us the chocolate story again?" Now, when that happens, I know that I've succeeded because that story has now become part of the culture for this organization, and they're never going to have to do that again if they keep that story alive in their organizational culture. Here's a great one. Britain has 17,000 pregnant men. Well, of course, what's happening here are some bad keystrokes, but once again, no ability to go back and find out. So they have people that are proposing to do dissertations on these 17,000 pregnant men that were in there. Again, it's just, you can see the article's data, but it's still happening today. They have problems with it. If we go back to the pandemic, poor Microsoft, not knowing, and why would a knowledge worker have to know this, that they were using an XLS file instead of an XLSX file, because the behavior of the XLS file was that it dropped rows that went beyond 65,000. So if you entered more at the top, you lost more at the bottom. And they ended up with 8 incomplete days worth of data in order to pull all of this together. It's one of my favorite ones. Happened to me. The microwave oven retail price was $40. Being a guy, I had one. And being a guy, I also dropped the glass plate pretty quickly. So I got online at the GE store to take a look, and I found, what am I looking for? Repair part. Hey, we're doing great so far. What have we got? A counterwave microwave. Look at microwave in here. Look for the repair part that we're trying to find. Let's see. Let's look for. I looked for things, I looked for things, I looked for things. Finally, I found a schema, and I went to the schema and found out that this glass plate was called a tray-cooking. Cool. Now I've got what I want. Oh, wait, the price over here is $48. That's more than the microwave cost. And when you add shipping to it, it's $56, $57. I'm not sure this was an intentional quality, but you would never solve this problem using just tools. You need to have the selective perspective of everybody that's involved in this. Data is not broadly or widely understood. Consequently, people come to it in the same way the blind people come to the elephant. They start out with one part of it, and sometimes they learn more, and sometimes they learn all of it, but for the most part, it's still kind of a difficult process to get through. Oops, I'm going backwards there. Sorry. Let's see. There we go. Data quality is going to resonate in different ways. Whoops, different parts of the organization there too. Sorry if I'm giving anybody a headache there, but these were signs they had in the airport for a long while. And the idea, of course, was that different cultures are going to perceive things different way. And in many ways, data quality challenges are very much like that. But data knowledge in general is too little and too informal, much less data quality knowledge. So if you have some of this, first of all, consider that you're a scarce commodity, and we'd probably have to other people get you involved in this. Here, for example, is an illustration of how your knowledge workers are going about learning how to access and manipulate data without your guidance. And there are some very clever results, but the question is, of course, what do we want our organizations to get good at in order to do this? Because data and data practices become the chaff in the machinery, and it makes lots and lots of little data cuts and hurts everybody up. Similarly, we don't want people thinking that data is the new oil, that oil is, in fact, better, more valuable the more it connects with it. So we need different knowledge, skills, ability, and all of this. And there's been a lot of challenges around getting business decisions right. But what it comes down to in the long run is that business decision makers and technical decision makers are not data knowledgeable. This produces bad data results. When it produces, bad data decisions. When it produces those bad decisions, those result in poor treatment of data assets and poor quality data that's in there, which results in poor organizational outcomes. You can see the secondary effect is always an effect here. And this is a cycle. We want to get out of this cycle. I sample Morgan Freeman there. He says, this is wrong. And the answer is yes. I'll give you just a very quick example. Salesforce has tremendous challenges because when they go in to put this very fine software in place, they oftentimes have the same problem that I started with on slide 2, where somebody foreclosed the old data into the new system. And unfortunately, Salesforce gets tarred with the brush with somebody looking at the system with bad data in it and saying the system is bad. No, the system is good, but the data in the system is bad. And unfortunately, most are not able to understand that distinction. So we've got to get away from data quality and help everybody get to data quality engineering, which allows us to get into these practices in a whole lot better place. Let's look at what we need to get better at. And the first one is systems thinking. I won't read you the thing, but it's the idea of seeing the forest and the trees at the same time. Here, for example, you're seeing something called a flyball governor for flow control, and it's spinning faster. When it spins faster, those two weighted balls at the bottom spin further and further apart because it's going faster, and that converts the flyball motion to a downward pull, which then causes the lever to go upwards and causing closing and restricting the fluid that comes in there in order to do this. Well, all of this, of course, is completely dependent on data, and data has got to be a major component within all aspects of this. We can look at this again from an engineering perspective by just a simple input-output process diagram, IPO diagram as it's called. If the IPO diagram says make pizza and the inputs are dough and water, anybody on this webinar knows that that will not result in pizza. It will result in pizza crust. So we have an option of changing the outputs and changing the process names, and now we have it consistent in order to do it, or we would have to add some more ingredients into this in order to make it work the other way. Well, from a steward perspective, we want to know all of this material. This is, of course, perfect information, but they are going to try to get there. They'll know what are the major business processes that we're trying to find out about, and what are the outputs downstream from it. This gives you a start of a roadmap to understanding all of these things. We have to understand how long these challenges are going to take, though. If we ask the question, why is infant mortality so high? The answer is malnourished mothers, definitely a data quality problem, right? Why are mothers malnourished? Well, they have substandard biology educations in this one location. Why are the biology programs substandard? Well, the washout rate of PhDs was sending them to a high school biology teacher. So they were unhappy and also not the cream of the crop. And so why do we have that? Well, the biology profession wasn't aware of consequences. The important point of all that lead up is what units should we use to measure the progress? And again, from a quality perspective, measuring this thing weekly is not going to help. It should be years minimally and decades likely, which means we should treat it appropriately. There are also some interdependencies between quality, which are critical to understand in there. And it's typically that you're going to have 3 sets of operations that are going to go together in one data management operation around this, and particularly if you're improving quality of data to something. I mentioned earlier the Plan, Do, Study, Act, Plan, Do, Check, Act, the Deming cycle. Many of you are hopefully nodding your heads. Good stuff. Don't reinvent the wheel, right? Well, phases again. We're going to take an idea and figure out what is the cost and the impact of doing this. I had a friend who worked for an organization for 3 years and came back and said, I solved one data quality problem for you for each year that I was here, and there were a good deal of savings, but all 3 of the variables that were solved for started with A, and unfortunately none of them had any real impact to the organization. So again, planning critical, deploying the resources, getting out there, doing data profiling, whatever it is that you need to do to investigate this, monitoring how that remediation is going to take effect, and then reacting around the other way. The extended data model, in this sense, the starting point for new systems developed, which is not where most people are, goes that way. And the starting point for existing system goes the opposite direction. Very important to follow that particular process through. Starting backwards. It starts at a different place, but it goes through in exactly the same way in order to do these. So let's get to this process of how we get better at this. It's really a key, first of all, of understanding what the focus of the organization should be. It should be on what they've told their investors or their responsible individuals, their governors, if you will, what they're doing. Again, while the use of the word strategy is relatively new, it's best not to think of it the way most management consultants think of it, which is of this massive document that you have to pull out and guiding you step by step, because that is a thing, whereas the origin of the word strategy comes from the military, Chinese in particular, and it's a pattern in a stream of decisions. Well, that pattern in a stream of decisions means is now a process rather than a thing. And from a data quality engineering perspective, we need to look at a couple of different aspects. First of all, the steps, I'm so sorry, I'm going to go back one, there we go. The steps that we're looking at here mean that we can allow the form of the problem to guide the form of the solution. You don't want to start out with the hammer if the problem requires a different type of a tool, a rake perhaps, in order to do that. That there should be some guidance in decomposing the problem into smaller pieces, feature a variety of tools, techniques that will simplify the understanding of the system, offer a set of strategies getting us towards the programmatic solution, providing criteria for evaluating that, and then facilitating a development of a framework for developing organizational knowledge around this. Gosh, Kim, does it sound like I'm doing a commercial for Reltio in here? Yes. Again, not that we'll get into that aspect of it, but it follows all of these guidelines in here. You can beat me up later on if that's not right, Kim, but I'm pretty sure it is in there. Let's take a look at some of these data quality conversations. I'm going to go clean some data, you might say to the boss, and the boss says, so what? Whereas if you say, I'm going to decrease the number of undeliverable targeted marketing ads, the boss is going to say, oh, that's a good thing, right? I'm going to reorganize the database. By the way, if you don't know why reorganizing a database can have an impact on data quality, hit us up at the end. We'll give you some good responses there. Instead, say I'm going to increase the ability of the sales force to perform their own analyses. Ooh, yes, that is a business result we would like to see. Develop a taxonomy. I'm shuddering here, right? There are just some people you would never say that to. But every leader in every organization has a challenge around creating a common vocabulary for the organization. And that is, of course, precisely what's occurring there. Optimize a query. Doesn't sound too good if I'm going to put that down on my 3 to 5 bullet points that I did last week. But if I shaved a second off of a task that runs 1 billion times a day, that would be 250 million seconds, which adds up to a significant amount of compute in the sense that somebody is going to care. Reverse engineer the legacy system. But if we want to understand what is good about the old system so it can be preserved and what is bad so we can improve it, we should work on that. The unfortunate term that occurs from all of these is the wonderful word munge. I hope most of you are not hearing it the first time today. Munge has its own Wikipedia page out there. It is jargon for a series of evolutions that a file typically goes through as one is getting it ready to actually be analyzed as a data scientist. It is a skill that we unfortunately do not teach enough of, and it appears to management as general alchemy. So we would like to help the data science community understand some of these additional pieces. And as I've already mentioned it before, adding 1 person to a team of 10 will generally produce a much higher return on investment than the cost of the 11th person to the team. Data quality engineering, again, it comes in, it's kind of merged. We're going to clean it, we're going to group it, we're going to organize it, we're going to change the date field. We may correct factual errors about it. We may eliminate all the missing pieces. Oh my God, did he really say that? Well, let's just say it happens. When we do data analysis in general, it's unfortunately a bit of a bleak picture. For example, if I told you that half of the analysts' time was spent munging their data, you would probably be disappointed because you feel like you're only getting 50% of every dollar that you're investing in that particular process. Well, we'd like to have it be something closer to that, where we've made maybe 20% or 0 would be a great number too. But the reality is that every single one of them will tell you that they spend 80% of their time munging the data and only 20% of their time as highly skilled data engineers, scientists, analysts, et cetera, et cetera. They're only spending 20% of their time doing that work. So not knowing this, organizations have incredibly unrealistic expectations around them. And they're not still all of the agreement that all organizational challenges have data roots. Let me illustrate a quick one here. It helps if you have a burning bridge issue. So the little quick video I'm going to show you here is the brand new Nike sneaker, which you can see is already burst open.
Williamson's Nike sneaker busted open on the court less than a minute into Duke's Wednesday night game, the star forward went down hard. And so did Nike. The company's stock sliding on the news, closing the day down nearly a point, losing an estimated $1 billion in value.
That is a burning bridge issue. And it sometimes helps if your organization has one because something is happening now and they need to do something about it. The challenges, of course, is that you also have to have them pay enough attention so that they understand what's going on. Most often, organizations are told to go buy something, a technology-based purchase, and get data qualitying. And again, the fool is still a fool with a tool. Something is accomplished, but most of the funding ends up getting used up. The early cases that you take on have a dual purpose. It's got to fix this immediate challenge, which means somehow it's got to be worthwhile in order to do that. You have to have some sort of cost benefit analysis that somebody can relate to, and also illustrate why this programmatic approach is preferable. I mean, the math is very, very simple. If X is invested in Y, then outcome Z will result where Z is greater than X. And at the beginning of the project, where the parties know least about it, all are expected to agree to all of these subs. X is some resources, Y is cleaning a set of data, and Z is the data that'll be clean. Everybody goes, so what? But if instead we move it around and say, define X is $100, Y is cleaning one set of data, and Z the benefit from $1,000, now you have somebody's attention. Another challenge around all this is that everybody wants to know when you're going to be done. Well, data quality is not a project. Data is a durable asset, and it will live for more than 1 year. It should be treated as such by the accounting profession. We're getting to the point where that may become more possible. Many, I won't say many, but some significant parts around the world are now starting to consider treating data as an asset. Again, the evolution is measured in years. It's relatively speaking more stable than the processes that are there in order to do this. And it's a ready-made it's a ready-made architectural component. And these are important prerequisites to Agile development, because if you're developing Agile and you don't have your data architecture down, you might as well just be creating silos on purpose. You will no longer need a data quality program when you no longer need your HR department. And that's important to start helping management understand the importance of that concept, because it's going to be a long-lasting piece. It may not be as long as as intense as it seems to be initially, but it is absolutely there. So, for example, what do we mean by a program? Well, there's an ongoing commitment. It permits some kind of evolutionary improvement, applying year-on-year performance and constant improvement. Governance that has some senior level direction and control. Leadership that is charged with accepting the risks around this. And again, specific budget priorities, helping scope things and keep title reasonableness around all of that. One example to think about it is the way they maintain bridges in New York City. They have a special team that knows that bridge inside and out, and you basically are part of that bridge for an extended period of time. And you start painting at one end, and when you get to the other end, you maybe take a week off, and then you start painting again. You've timed it so that it's continuously maintained. It means that you have a knowledgeable workforce. And we need to think about data quality in exactly the same thing. In this case, it's being governed at the appropriate level, which is bridge specific. Each one of the bridges in New York City is completely, well, I won't say completely, but they're all different. And so the governance needs to be focused at that level. I said some words in 1980 when I was working on this book with Clive Finkelstein, who remains my mentor in this entire journey. But the question is, why haven't organizations taken a more proactive approach to data quality? And Clive's answer was, stuff's not easy, you know? I mean, first of all, if you start talking about it, somebody's going to want to audit you or something like that, and your efforts are likely to be misunderstood. You could make things worse. And by the way, since you found it, you also get to fix it. And yet, we've all seen over time, a single data quality error can grow into multiple different types of activities that impact other things in the organization. They are the proverbial hidden data factories, to quote Tom Redman on this, where Department A has some data, some work products that it's delivering to Department B, and Department B has gotten tired of telling Department A to correct its work and instead just corrects it for them. That's a hidden data factory. Department C has similar problems with Department B's work, so that's another hidden data factory. And of course, there may be a customer interaction where the product comes back from the customer, another hidden data factory. In fact, they are all over your organization. And if we can find these hidden data factories and suss them out, we will have a much better throughput of our organization, efficiency, effectiveness, again, faster, better, cheaper, less risky. So let's just examine one of these hidden data factors a little bit better, because it turns out they all share an interesting characteristic. First of all, they're all filtered through an IT system or a business process or some combinations thereof. That means there's an awful lot of material in there that we've got to figure out where it goes, why, and what's going on with it. And if we connect the dots, we'll understand that fixing this one hidden data factory will help our organization in this instance here, 7 different other areas. This root cause analysis always reveals that data component. Data is a root cause of all business problems. And we also need to understand that if we're going to do this, we now need to have a specialized team with repeatable practices and processes that develop skilled organizational skill sets in this area, that we understand these pieces, and that gives us much better ability to deal with them on an ongoing basis. I was at a logistics company in the Midwest at one point in time. It was a great organization, but I saw this room here that I've pictured down here on the bottom of 100 associates. And of course, I'm nosy. I asked the question, what are you doing? And they said, we're manually correcting every item on every customer invoice. The customer's name was wrong. The date service provided was wrong. The type of service provided, the outcome of the service, the price, everything literally was wrong. And they didn't want to get egg on their face by sending out these bad invoices. So they had developed a room of 100 people who were taking every invoice and taking 30 days to correct the information on this so that they could send out the invoices, but they were all 30-day late. I noted to the manager and said, there's a better way of approaching this system. And the manager said, well, this is the best quarter of the best year that I've ever had. I'm thinking of doubling the number of people in this room. Again, these are not people who are not smart. They're smart people, but they do not see the entire picture. And so when I marched down the hall to talk with the chief financial officer, she simply looked at me and said, if you can fix this problem in 1 month for less than $750 million, it's a positive return on investment in 30 days. Of course, that wasn't possible, but it was certainly possible to address the data quality problem that they had in less than $750 million. And that was because the organization pulled in $9 billion annually, but got its cash flow delayed by 30 days. So again, a proper engineered challenge made all the difference in the world here in order to do this. So we're getting close to the end here, and the musical analogy is good. Both Shannon and I are musicians and love to play and sing and work with people on this. And there's the old joke, how does one get to Carnegie Hall? And the musician says, well, you got to practice, right? Well, you got to have good music, but you also need to have that ability to go in and set up a program that is going to allow you to do things on a regularized basis and build up a sustainable skill set. The two of those together are going to result in much better approaches to organizational data quality. So got a couple little conclusions here, but we've again gone through these 3 phases of approaching data quality, understanding what it is we need to get better at, and then how to go about doing it, measuring that tangible return on investment, each one. We're getting to the takeaways, but just a couple of quick things as we're rounding the corner to the top. First one is that it was taught to me a long time ago, and I hope to all of you as well, if others do not understand what you do, there's a cost bias. They think you are costing them money. But if others understand what you do, then you can be perceived as having a value bias. So I just want you to be very practical. You yourself are getting paid. We'll pretend it's $1 million a year. That's a wonderful thing. And it's incumbent on you at the end of that year to be able to demonstrate to the people who paid the bill that you have provided at least $1 million in value to the organization in order to do that. Very, very clear that all of these data quality engineering initiatives need to be costed out, need to be put in place that is going to work. Now, this slide, unfortunately, is one of the things we see oftentimes as consultants. People hand this to us. How do you like our data quality program, right? Well, it's not a data quality program. It's a bunch of words on a piece of paper. Until you can have people who are, this is really the measure of success that you're looking for, able to sit in the corner, who are disinterested, who say, yeah, I saw them clean up that data quality. It made my job easier. And by the way, I can put a dollar cost on how much easier it was for me to do that. We no longer have to run overtime or whatever the particular piece is. It's, again, got to be incredibly more helpful. In fact, if you're going to start out with this, there's a sort of settle a success formula here. The project needs to be generally small. And no project should be allowed to begin unless the data requirements for the entire project are verified. That's the architecture all the way around. Second attribute is that the product owner or sponsor or subject matter expert must be at least somewhat skilled in data to understand what it is that's going on, because few in IT have the requisite data skills and knowledge, and that's just an unfortunate occurrence. The process has to fit in with whatever the organizational IT processes, practices already are. There's no point in trying to get everybody else to change to your perspective. We need to adapt to theirs. So they are doing a lot more of this, and it's working reasonably well. Number 4, the team must be highly skilled in both data quality and in the technology, whatever technology that you've decided to enlist in there. Few of these teams have these requisite levels, and it's really worthwhile to try to get this into your recruiting process if it's really important. Piece 2, finally, the organization must be at a high level of maturity, because it's going to take some significant investment. In fact, the approach only works if we know where the data that needs to be fixed resides, that we can communicate precisely and correctly amongst team members, sponsors, collaborators, and we're adept at the correct type of technological support. But what, unfortunately, we really could get better at is that we're good at celebrating when data things happen. But I put the approximately equal sign on there because we haven't been as good at understanding how we need to celebrate organizational things happening. So I gave you the example over there of just the different perspectives that people have. Again, we'll just go back to revisit one of them. If the data person says, hey, we reorganized the database, manager's like, yep, and so what? But if we go a little bit further and say that, and as a result of reorganizing the database, the salespeople now no longer have a backlog with IT in terms of developing dashboards and analyses. They're able to do their own thing in there. And that has resulted in a, let's just say, 3% sales increase in the first week. That's the dollar sign that people want to see on these activities. It is extremely, extremely difficult to sustain these things if we don't have it working in that fashion. So I'm going to stop here and go back to one thing because I want to show you an aspect of this. I think this is number 7. Nope. 9. Nope. 12. Almost. Yes, there we go. Got that. Remember these 4 attributes we talked about at the beginning of the hour? These are relatively incomplete definitions. And so as a bonus on the very end of this, for those of you that really want to get in and dive into this and study it at kind of like the master's level, we'll go to those right now there. So here's our, again, representation, value, model, and architecture. Great stuff. What we really need to look at is this piece, which is, sorry, still 107. There we go. Each of these dimensions that I defined earlier, we've provided dimension definitions around here. So you can actually use these 10 attributes here to start your very own look at this. one of your first questions is going to be which of these are important, which are not. There's the ones for value, the ones for representation, the ones for model, and the ones for architecture. So that'll give you something to take a look at as you're working through your first data quality pieces. And we're just about at the top of the hour, so it's time to let Kim back on and see what questions we can answer for you guys about data quality. It's such a great topic. Again, don't forget to visit the bookstore, blah, 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 blah. But more importantly, Shannon and I are announcing today that we're looking at a refresh for this event as it goes into its 15th year in January. So Shannon, congratulations to us for surviving this long, and thanks to you guys for making it successful. We got a couple more this year, and then in January we will start the new piece. And with that, Shannon, we're over to you.
Peter, thank you so much for another great presentation. Yes, 15 years. I look forward to our 15th year of this webinar series. It has been such a pleasure, and I think you'll all love the agenda that we have put together for next year. But in the meantime, if you have questions for Peter on this webinar, and if you have questions for Kim, feel free to put them in the Q&A panel. So diving in here, Peter, I love all the reactions. It's I love
thank you guys.
Yeah, right. So, oh, by the way, so what's the name of the book again that you mentioned? It was somewhere between slide 40, before slide 41.
Holy moly.
I know. Something messy.
Oh, how to fix any mess. Abby Covert. Yes, a wonderful, wonderful book. Let me pop that back up there since somebody does have a question about that. Thank you, Shannon. That's really important to give her her due. You did a great job. Yes, it's a Kindle book if you have Kindle, so you can just grab it right out from Kindle, and it explains what information architecture is to people who are not information architects. And I'm going to go back and do that one more time. I still went. Anyway,
yeah.
Shannon, can I ask
I like
Kim if I represented Reltio correctly when I gave the simplification response?
Of course.
Yeah, Peter, I think you were spot on. And again, defining some of those data quality issues that you had at the beginning there, and then we recovered at the end. That's what we hear across the board. And again, hopefully give some of our customers a place to programmatically change and update and correct some of those issues.
And Kim, you don't actually sell it as a data quality component, but there's obviously things you can do with it if you employ it towards data quality. So I'll just leave it at that, and we will get into it with some of your questions in there.
Great.
Perfect. And I found a
Shannon
link
will tell me nobody has any questions, right?
Nobody has any questions. No, yeah. No, I did put a link in the chat to the book.
Thanks.
And with AI now automating so much of data matching, cleansing, and anomaly detection, do we still need to invest as heavily in traditional data quality programs?
A really reasonable question. Kim, you want to try that one? Or you want me to take a first crack at it?
Yeah, I can start.
Jump in.
First and foremost, I think many companies are still hesitant to let AI really loose on data and changing data. So we definitely still see humans in the loop for data quality issues and review. Again, this is where some of that auditing and compliance and trackability really comes into play too. So you can always know, did a person change this, or did an AI experience make a change here? So, I think it's, to answer the question, do we still need to invest as heavily in traditional data quality? I think it's just going to look slightly different as the space continues to evolve in terms of where you need to invest to have good quality data. What can AI do? And then to come full circle, how can the data be used maybe in other AI experiences as well?
I agree completely, Kim. And I think really important for all of us on the call here to think, again, just some very wise words of wisdom, which is that AI is not going to take your job. Somebody who knows how to use AI better than you is going to take your job. And so thinking of how AI can be used in conjunction with this, I put the Joni Smith example back up here. on this. There's certainly some things that AI can do. It might, for example, suggest all of these things come together. In fact, if you've been working with any sort of mail merge program at all, you know that a lot of them have this built into it, and they're just now calling it artificial intelligence. But there are, in fact, artificial intelligence applications that you can bring to this that would be very, very useful. But probably it's still going to require the knowledge worker who is responsible for this knowing how to understand and use AI to help them do their job better if identity resolution is in fact their responsibility here. So again, we may have just some people that create it from an awareness perspective and others from a I got to fix it perspective, or some people just say, well, I just report it and then I leave it at that. Somebody else takes it from there. We're going to have an increasing importance of the ability of the people who are charged with this type of work, particularly those of you that are getting into investigative work. Again, sounds a little bit silly, but some of you are developing specialized skill sets in your data governance groups and are sniffing out and addressing these data quality problems as a way to point to management to say, hey, look, you invested X in us and we've produced X plus in a year. So asking you for next year's budget is pretty much an easy understanding because they paid off well in the last investment. They're going to pay off well in the coming investment. So anyway, Kim, any final thoughts on that before we go to the next question?
No, I think we're good. Let's
Super.
go to the next one.
Great. I love it. So if lots of AI questions. So if AI driven tools are taking on much of the workload, is the future investment of data quality more about governance, stewardship, and compliance than about data cleansing itself? Very much along the same lines, but with a slightly different angle.
Why don't I try that one, Kim? Once again, I think go ahead.
Go ahead. No, go ahead, Peter.
So once again, we are going to need people that understand what AI can do. It's one thing to tell AI to just organize something according to a certain piece of this, but when you get into literally, millions and millions of rows, there's no way of doing any sort of visual confirmation on this. And yet I fooled myself many times working in spreadsheets and other things thinking I had done something, and I'm always so thankful for the undo buttons that allow me to go back and address this. Yes, certainly AI is going to try to pick up more and more of these, but once again, the focus is not just that you have an AI that does this, it's that you have a skilled knowledge worker that knows how to use this in support of their job function. Over to you, Kim.
Yeah, and in the Q&A chat there, Rick made a good point. AI tools can be really expensive, and it's, you can get a lot done in data cleansing without AI through, again, programmatic cleansers and data enrichment and things that don't necessarily need to be AI driven explicitly, at least for the bulk of things, right? Maybe we're doing 80% of data cleansing in some, configured ways, but, there's another 10 or 15% where AI is going to be really helpful there, right? So think about not just what tools you're using, but costs associated with them. I don't think we need to use AI for every use case just because it exists. So, take a smart approach to the holistic view of data cleansing, as well as governance and stewardship and compliance, right? And then leverage AI for those really tricky things where there's greater value if it's an expensive tool.
And again, practice, practice, practice. It's the one thing that really will show you how well it can support your specific activities that you're looking into. Again, great questions. Thank you, guys.
Agreed. And if you have questions, we've got plenty of time, so feel free to put them in the Q&A panel. And I get, I gotta say, I get a little bit of anxiety, Peter, when I hear practice, practice, practice. I was like, oh, what do I need to practice right now? What's my music score right now that I need to work on? But next question, how would you recommend a proactive approach to data quality if the data is ingested from a third party? So, for example, you can't implement quality rules in the source system.
Cannot. And I can recall doing a analysis of a third-party data stream that was supposed to provide a replacement for subscription data that was coming in for this particular organization. And you can't control the source data, but you can at least control the deliverables through an articulation agreement or some other type of, there's a different word for it, and I'm losing it here, Kim, maybe you can supply it. But, you know, just that you have an agreement, surface level agreement, there we go, that's what I was looking for, that says, you know, data will meet certain standards. And if you have an idea of what those standards should be, then you can create a test against that when it's coming in and hold them to the contract in there. And so again, it's important that we think of it not just strictly in technical types of responses, but also in terms of process-oriented responses, which are really going to be key. And again, go to the previous question as well, that there's just an awful lot of materials that are not going to show up, you know, with that, because they're buried in you guys' expertise that you have in order to keep all of this under control in your various organizations. Kim, any thoughts on that?
Yeah, and you know, the scenario from like a third party, right? How are you using that data? Where's the point of activation of that data? And is there something in the middle that can better help control data quality there, or, you know, allows you to build in rules to say when you want to use that particular set of data? So, you know, anything that's going to give you some of that agility and control is going to help build a stronger practice for, you know, the entire ecosystem you're working with.
Mm-hmm, mm-hmm. And again, you can also build expectations organization-wide as they start to use this improved data and say, look, we don't want data that's of poor quality. We want data that has certain aspects of it that we understand and are able to count on. Shannon, while you're getting the next question up, I'll just make a point that I had 3 people respond to my email that I had suggested improvements in data quality in my email communication with you all. So I heard those. I think I responded to everybody who did in order to do that. And I'll show you one other quick one here too, which is that on the one front slide here, where if you were watching this when we were getting started, you'll notice it's got a little running header down a chiron at the bottom of the piece. And I made the mistake when I built this thing by building the actual date of the webinar into it. So it says September 13th. And it'll pop up here in just a second to join us on September 13th. I didn't put the year, which was good, but I clearly could have done better by just saying join us, right? Instead of trying to be too precise about it. So it's easy to make these kinds of mistakes to still have them in there, but we really appreciate you guys helping us improve all the way around. Did I stall for you long enough, Shannon?
And you did. Thank you. Yeah. I like it. I appreciate it. Yeah. So, and I can get you a copy of a link to the survey too. I'll get a link to that survey. But the next question is, you know, data quality starts at the data's point of entry into a system. In an OLTP system, simple data domain rules enforcement through edit rules. Isn't that a simpler start before applying AI?
So we'd have to have, I believe, a specific context in order to actually answer that question correctly. But it does imply that there's a trade-off that's there. And again, if you think about it just in terms of these dimensions that I have here, there are going to be a lot more representations of the data than there are values. In other words, the value 42 might show up on a watch, it might show up on a mobile phone, it might show up on a display that's in the room, it might show up on a desktop computer. Those are all representations that are there. And you know, fixing those is the most obvious place people go, but it really represents typically a superficial analysis. And we need to find out whether 42 is the right number. And in fact, whether 42 was related to the things it's supposed to be related to in the data model up there. And then that is part of the overall organizational data architecture. So it very much is a multiplicative role, and we don't want to, we've lost an awful lot by focusing on just the lower 2 aspects of it. Again, the practice related versus the structure related types of activities. And Kim, I noticed you used those words in there. I didn't mean to make fun. Were those you guys' beliefs as well as far as the practice and structure related?
Yeah, absolutely. Right. The reality with data and the role that it has been elevated to in most businesses is it's a technical conversation, and it's also a people and process and practice conversation, right? Um, so all of those things have to work together, right? That's data literacy that we talked about as well. So they really go hand in hand if you're going to have a cohesive solution there.
Fantastic. Yeah, I've actually just had trouble getting people to buy into the fact that they are different in terms of what we're looking at and that require different approaches. But again, the idea that simplification of your existing environment, if nothing else, is one way to do this. On the other hand, I'll give you guys just a quick glimpse into it. There was a very large bank at one point in time that discovered that it had literally tens of thousands of databases that were the wrong type. They were Microsoft Access, and these Access databases were running in production systems. So they had to go through as a data quality exercise and get rid of them, and it literally took them 10 years. I was involved in the project at the beginning, and I was involved in the project at the end, and it was simply fascinating to see what kinds of quality challenges that they had around that. Too much storytelling, Shannon. I'll get back onto the
I
questions.
think you can never have enough storytelling. It's good. I do like it. So if data quality model is already matured for an organization, should we focus on solving data issues? Should we also have periodic review of rules, business usages, and impact?
I think the answer is yes, but Kim, you want to try it?
Yes, definitely, right? The data that you're reviewing, even at a mature organization, is probably going to change, right? No company that I've ever talked to is not bringing on new systems and applications from time to time, right? So they're going to be contributing new data into your ecosystem. So it's a living, breathing organism. And so, if you let it just run wild, you'll inevitably come back around to some additional data quality challenges, I think.
I'm working on a book on data leadership, Kim, and the one of the main themes that comes from the people that we've interviewed in there is, I think, what you alluded to. You may know how to address a data quality problem, but what we don't know is how to address it at your organization. You are the expert there. And so that is going to require a relatively important recognition of your role in addressing these problems. Again, just a quick story here, but I went to a hospital at one point that their hospital director made an announcement in front of the rest of the world that they were going to be doing more knee surgery. And that's one of the reasons I put the knee surgery example in the little talk. And the problem was that I watched people in the back of the room and they were kind of shaking their heads, and this was not a happy result on this. So of course I snuck up to them after the presentation and said, "You were clearly unhappy. What's wrong?" And they said, "The hospital director doesn't understand that knee surgery is the default hospital admission code. It's not good data that individual is working with." So these types of things are really important for organizations to get a grasp on them and to make sure management pays attention to it. Just one more thing and I'll shut up. And that is that I use the 4 words to describe data governance, which is managing data with guidance. But as we're working our way up the organizational ladder, we find that it's also very important to manage organizational data decisions with guidance. And management does not realize they're making data decisions. They think it's just some techie thing, and it doesn't really impact their business. And that's where we've got to get better at articulating all of those aspects around it, because it's not a trivial problem. As you can see here, it's got a lot of different aspects that we need to think about.
A lot indeed. And we've got time for more questions. We've got another one coming in here. Do domains seem important for improving data quality? How would you recommend creating domains, by a department level or a program project level?
Kim, you want to jump in there while I search for a slide?
Yeah. So the the way that, at least I view the world when it comes to domains is taking an object-oriented approach. So we tend to think of, a customer domain, and that might be either an individual person that you're doing business with or a B2B organization, if that's kind of how you do business. Right. So it's those core components along with related entities or domains that drive your business. So that's kind of how Reltio sees the world through the lens of domains. But I would say that's something that folks probably have different opinions on as well.
I think, though, that you hit on the key, which is that there's inherent leverage in there. And so, once again, if you talk about, again, I'll make a probably politically incorrect reference here, but I worked on a legal case where under Canadian law, they had to maintain 9 gender codes: male, female, formerly male, now female, formerly female, now male, uncertain, won't tell, doesn't know, male, soon to be female, female, soon to be male. I can actually reel those off in my brain. And it was critical because the people who were doing the conversion had converted using code that basically said, if M, then male, else female. And of course, they lost all of the other values that were involved in that process. A unfortunate data quality error, but more importantly than that, it actually resulted in legal liability for this organization because their insurance wouldn't pay the judgment that they ended up with them, and they were quite close to going out of business at that point in time. So, Kim, you probably weren't thinking of a dreadful, am I, existentially going out of business story based on domains, but I think that is one example that we can use.
That is a good example, and thank you for this. That's all the questions that we have, though.
Oh my goodness, we wore them out, Kim.
This is great. No, great questions.
They've been really good questions, and it's such an important topic. Thank you so much, Peter, and thank you so much, Kim, and thanks to Reltio for sponsoring and helping to make this webinar happen. Again, just a reminder to everyone, I will send a follow-up email by end of day Thursday with links to the slides and links to the recording. And I'll throw in a link to the survey there that I put in the chat and to the book. So hope you all have a great day. And yeah, so Peter, I see you're putting up next, that's December, yeah. October, data strategy. Oh yeah, that's a great one. All right, I love it. Thanks, y'all.
Kim, thanks so much for joining us. Yeah, absolutely.
Of course. Thank you, Peter and Shannon, for having us. Appreciate it.
Have a great day.
Cheers,
Bye, everybody.
everybody.